Afternoon, everyone. Okay, sorry, there's a problem with the link. Good afternoon, so there is waiting for student of my class because have a problem. Okay, now please. Good afternoon, everyone. Thank you for joining this webinar. Today we have this lecture from Universiti Teknologi Mara-Malaysia. We have Dr. Nurul Hafizah in Teknologi. Hello, Dr. Nurul. How are you? Hello, Dr. Nurul.
Hello. I cannot. Your voice is not very clear.
Okay.
Is my voice okay?
Yeah, your voice is okay.
Oh, okay.
Okay. Today we have talk about how factor used in everyday life. Okay, Dr. Nurul, time is yours.
Okay, thank you. Okay, I will share my screen first. Okay, can you see my screen?
Yes, we can.
Oh, okay, thank you. Okay, so Assalamualaikum and very good evening to all of you. Good afternoon, I think, because here we are still two. So thank you for having me. I think this is my third or maybe fourth time with Linus University. So, but with different topics. So today I will share with you, it's not like teaching on vectors because you have learned this topic, but it's just like a sharing session. So thank you for having me. And also I do invite some of my students, and I see there are a few of them. Maybe some of them are still having problems signing in because I signed from my email and have some difficulty just now. But it's okay, we managed that. So I know that most of you are actually all of you are from taking courses linear algebra, right? So for in linear algebra, we start with matrices, and then just a little part of vector. If I just go through your syllabus, there is only a little bit of vector, like vector to scalar, just like vector operation, vector projection, what else? Dot product, scalar product, but I just see just the subtopic, so I do not know what exactly that you learn in this linear algebra course. But I've been teaching this course too. So basically, I think the foundation is the same as long as the course is linear algebra. And then based on my previous seminar, the audience is from different background. Okay, there are engineering. So maybe you can comment at the chat box from which program. If I'm not mistaken, you're undergraduate and taking other different programs, and there might be engineering courses. You can just put the comment at the chat. So I will look later. So my students that I invite, because the schedule given to me right now, I have another class, the online classes. They're taking introduction to mechanics. But at the same time, they learn about linear algebra in the same semester. So it's actually based, because mathematics for foundation, for undergraduate students, diploma, degree students, they learn the basic of mathematics, and this relate to whatever courses that you take, mathematics courses, it must be related to each other. So like introduction in mechanics, we also learn about vector, just a little bit of vector, and linear algebra. Linear algebra, you learn about matrices and then a little bit of vector. So basically it's a combination, is related to each other. So I just invite them, maybe they are familiar with some of the example because I just screenshot whatever example from their books yesterday. So I will just explain, just sharing what we learned here. And also maybe if let's say you guys have been learning this, maybe in linear algebra classes or in mechanic classes, physics classes. So it's just like, just sharing. Okay? Maybe it's not something new. Okay, but just you can just take it as an revision maybe. Okay, so how vectors used in everyday life. Oh, okay, I have to scroll down. Okay, so the table of contents, I will just share a little bit overview. Okay, why you need to learn mathematics, why do all courses, whatever program that you are in, you need at least one foundation classes of mathematics, foundation of mathematics, or maybe foundation of applied mathematics, maybe the name of the course. Yeah? So one of it is linear algebra, why you need to learn linear algebra. Okay, and then some example. Okay, so the question is why? Okay, this is just a sharing that here in Tapa campus, we have 6 program. Okay, only 6 program because we one of the branches of Universiti Teknologi Mara. So there are a few diploma program in UITM. So we have 6 program, and if you can see that every program must at least take one mathematics courses. Like me as a mathematics lecturer, I have to serve to different faculty, different program. Okay, so like accountancy, we need to teach business mathematics. Okay, for applied science students, pre-calculus, calculus. So this is the basic mathematics. So if you can see here that linear algebra is taken by 4/5 or over 6 program. So why is it important? And it is taken by mathematical science student, computer science students, statistics student, actuary students. Okay, so why they need to learn about linear algebra? So it's the foundation of more. I will show some example later on. Yeah. Okay, so I invite my students in semester 4 here today together with us. Okay, so if you can see here, do you see that when I scroll my mouse, do you see my mouse moving?
Yes, Doctor.
Okay, thank you. Okay, so semester 4, they took linear algebra and also introduction to mechanics. Okay. So mathematics is very, very wide actually. So we start with the origin, how people back then calculate. They do not have a calculator, of course, right? So how they calculate? They use a bone, and then they put a tick. Just do a mark on the bone, 1, 2, 3, 4, and then they learn about grouping the marking. So if you have 5 marks, that is one group. Then they learn about multiplication, division. Okay, so they start with that. Even if you want to learn about physics or chemistry whatsoever, it starts from the basic of mathematics. That's why some of the people says that mathematics is a universal language, right? Other peoples from other countries maybe learn about English, like we can speak English and I speak English, then you can understand. Or even if I speak in Malay, then maybe you can also understand because serumpun kan, serumpun boleh bahasa Melayu kan. But also mathematics is also a universal language. If let's say you are from German or whatsoever, 1 plus 1 is also will always be 2, right? So it's a mathematical language, and before exploring other areas, you need to know the basic of mathematics. Okay, look at here. We have the origin here. It's too small. Okay, but this one is starting from Persia, India. Okay, who perkenalkan. So who this one I cannot see. It's too small for me too. Okay, so this is the origin from Egypt. Okay, and then we further on to the number system. Okay, what do you mean by number? And then we introduce the infinity, exponential, pi, and so on. And then we have the foundation here. Okay, so foundation, if you do not know the foundation, then how are you going to apply to pure mathematics and applied mathematics? Okay, you have to cover this first, and then you can go to other areas. So where is linear algebra? Okay, linear algebra is a part of pure mathematics here, linear algebra here. Okay, and then also matrices is also in the algebra. Algebra linear because it is to the power of 1, and then we develop the equation y equal to mx plus c. If let's say you have more than 1, then it is a system of equation. So Okay, and then you learn about geometry too. But for at least for every program, if I'm not mistaken, normally they will take at least 2 courses or maybe 1, like calculus, okay, because calculus you will learn about differential, integral, okay. Like my research area is in dynamical system, fluid flow. I study the convection of a fluid. Okay, after the pure mathematics, you have a little bit of foundation on mathematics, then you can continue with to apply the mathematics. In statistic area, okay, then you go to probability, optimization, where is computer science. Computer science is also in mathematics. And the finance, and the engineering, numerical analysis, chemistry, physics, okay. So it developed from the origin. You must have the foundation, and then you need to explore. Okay, so in this talk today, I will show from how vector, when you learn about vector, you learn about, okay, there are 2 points, and then these 2 points is joined together with a arrow. This 2 point is joined by a line, has a magnitude, has a direction, is a vector. So you cannot see any people who do not understand, they will we cannot see any vector flying around us, right? We don't see, okay, there are 2 points, there are vector, because like I have friends that when we talk about mathematics, they will say we learn about calculus, okay, even as I said, like calculus is one of the common or the foundation subject that they learn for whatever program. So they said that they learn even in secondary school, right? We will learn about differentiate, integrate, but when we work, when we further on to higher level, we will not use it. Some of them will not use it. So what is the point that we learn? Okay, so actually everything that this differentiate integrate is actually is the basic mathematics. They do apply, but they do not see it. Just like us, we learn about vector, but we cannot see any vector flying around us. So today I'm going to share from vector how mathematicians sees vectors applied in our real life. Okay. Okay, so vector in real life. We will learn about vector first. Okay, so vector, we learn about the basic operation, projection. Okay, and then number 2 is force. Force is also one of the example of a vector. Why vector? The definition of vector is must have a magnitude and direction, right? So force is also must have this both direction and magnitude. So force is one example of vector. Okay, so when there is a force, there is an energy because of a movement, because of an action. Okay, so there must be a force. That force is from a vector. So when there is a motion and then you have a vector, you have a force, then you have then people scholar will introduce some law or some theory. Okay, so one of the famous theory is the Newton's law. Okay, I will explain later on this. Okay. Okay, for dot product, okay, based on your syllabus, I see that first for vector, you learn about dot product and also cross product. Okay, so if let's say dot product, okay, if let's say dot product, if let's say you have a vector A13, this one, A13, means you have a vector 1 and then 3, right? So this is vector A. Okay, vector A. Okay, this is how you present a normal vector. Okay, so if let's say dot product means you have two vectors, okay, A and B. 4, 5. Okay, so A dot B is 1 times 4 plus 3 times 5, right? So you will get 15, 4, 19. Okay, so this is a scalar product. So dot product is also a scalar product. So why do you need a scalar? Why you need the magnitude? What is then why is A dot B is important to know how to calculate it? Okay, so for example, A dot B, okay, there are one formula, A dot B is equal to the magnitude A, magnitude B, cosine theta. So from here, we can see that we can find the magnitude of A, we can find the magnitude of B, and also we can find the angle. So in real life, maybe you have two pens, okay? You have one pen and then you have another pen here. So the question is, you want to find what is the angle between these. Maybe you want to design something, then if let's say if let's say you do not know how to calculate, how do you do the dot product, you may use the protector, right? Protector, you just, put a protector here and then you find what is the angle, okay? But in calculation, you may, because you know how to calculate, you don't have a protector with you on in your hand, so maybe you can just use the formula, okay? A dot B. So you just find the magnitude of the length of this pen and another pen, and then you find the you can find the angle without using a protector, okay? So that is how dot product is used because of the formula, okay? Or maybe you can find the projection of a vector. Projection of a vector is the red marker here, the red vector here, the arrow red in red here. So this one is the formula. So you have a dot product here and also the magnitude. How to find the magnitude? There are the formula of magnitude of a vector. Okay, this is for dot product. Okay, and then how about cross product? So if let's say you're going to maybe want to design a house, maybe. Okay, so if let's say you have a plane, you have one plane, you want to find the cross product. You have a vector V. You learn about vector, right? This is vector U, this is vector V. And now you want to find, this is on a plane, and you want to find another vector which is 90 degrees with the plane. Okay, this is a plane, and then this is a plane, this is a plane, and you want to find a vector horizontally 90 degrees of the plane, but you only have two vector on the plane. So how are you going to find this? So you can use the cross product, U times V, U cross V. So this is U cross V. So if let's say maybe you want to find the height, the suitable height for the house, you want to design something. Okay, so you use the formula U cross V. If you want to design a house, you will not just straight away do the house, right? You have to model it first. So how you model it is by using mathematical model. You need to calculate first. So maybe the cross product is included in the calculation. Okay, the example here is area of parallelogram. You want to find the plane. You want to find the area of this plane. So you can use the magnitude of U cross V. If let's say you want to find a triangle, you just divide by 2. Just divide by 2, you will get the area of a triangle. So it's also an application without you have to take a ruler and then you do whatever, do it manually, right? So you just need to know the two magnitude, you cross V, and then you calculate, you cross V, then you get the area. And also if let's say you want to find the volume of a parallel pipe, this one, volume of parallel pipe, you combine dot product and also a cross product. Okay, so from dot product, from one formula you can combine other formula to make more and more formula. Okay, after you learn about dot and cross product and also some operation, projection of a vector, then I saw one of the subtopic is the difference between vector and also scalar. Okay, so vector, if I say, as I mentioned earlier, vector is a physical quantity that has a magnitude and also a direction. But scalar only have a magnitude. For example, if I'm the speed of the car is 50 meters per second. The speed of the car is 50 meters per second. So we know that 50 meters per second is a speed, is a magnitude. Okay, but we don't see any direction, right? So we don't see any direction. So we say that it's a scalar. So how this going to be a vector? Okay, vector, we must include a direction. So normally for direction, we will represent by angle. Okay, so if let's say this is a positive axis, we normally will do it anti-clockwise. So from the positive axis, 0 degree, 45 degree, 90 degree. But if let's say for a speed of a car, we will not say I'm moving 90 degrees with a speed of 50 meters per second. If let's say I said to my friend, I'm going to my mom's house in Bani, in Paris. Where is Paris? Where is Bani? Will you answer, oh, it's 270 degrees from here, right? We will not say the direction in angle, but we will answer it in northwest, the direction. We will answer in south. Oh, Bani is at the south. Okay, south area. So we will not say in angle. So that's why I say that people actually learn atau people do apply, but they didn't notice that they applied what the direction of vector. Okay, so vector is how the vector is represent. Vector is a scalar and also a direction, but direction doesn't mean that will always be in angle. It can be in direction north, east, west. So people who says that they learn nothing, I mean, they learn but they do not apply, actually it's because they do not see that they are actually that it is also is already adapt into whatever situation. Okay, so that is how the vector is applied. If let's say you are moving, so you can say I am moving, I drive my car 110 kilometer per hour to the north. So the speed is 110 is the scalar. To the north, drove to the north, so that is a direction. So that is a vector application. Okay. Okay. So this is a question, one example. A bat is flying steadily along a horizontal path and suddenly makes a sharp detour of 23 degrees and catch an insect located 3.5 meters from the detour point. As a normal person, normal human being reading this, or maybe our son, not my son, maybe my son, or maybe our friends reading this. Okay, just read. Okay, it's a normal situation. Okay, there is a bat and okay, it is flying. Okay, but as a mathematician, you see that 23 degrees is actually the direction. Catch an insect located 3.5 meter from the detour point to 3.5 meter is the magnitude. So actually this question is a vector, but when it is applied to some situation in real life, a bat, insect, then people will maybe will not see this as a vector, but mathematician should see this is actually an application of a vector. Okay, determine the x and y component. Okay, so obviously lah, this is a vector question. We have the x and y component because vector must have the x and also the y component. Okay. Okay, let's do this together. This is just a short question. Okay, a bat is flying steadily along a horizontal path and suddenly makes a sharp detour of 23 degrees. So 23 degrees is less than 90, right? So it's maybe like this, 23 degrees, and catch an insect located 3.5 meter from the detour point. So this is the point. So 3.5 meter is here. Okay, determine the x and y component of its detour flight. Okay, so we just need to consider this vector. Okay, so if let's say this is determine the x and y. Okay, so I'm not sure whether you have learned, this is not in linear algebra syllabus, I think, but if let's say you are from engineering background, maybe you know. Okay, if let's say you haven't learned, then it's okay. It's just sharing some of the application. So 3.5 cos 23. Okay, and then Fy is 3.5 sine 23. Okay. Okay, so you will get 3.22 and also 1.37. Okay, how about this question? If let's say normal people will say, oh, it's just a normal question, right? It's just a normal situation. Malaysia Airline plane flies 400 kilometer east. So where is east? North, south, east. Okay, from airport. Oh, sorry. From airport K. Okay, 400 kilometer. And then 300 kilometer, 35 west north. Okay, so look at west north. Here, west north. So it is 35 degree. Okay. So maybe here. And finally arrive at airport L. If a pilot of another airplane wants to fly direct from, okay, I think there is a typo here, should be from K, right? Okay, so the first one, the first plane move from here and then here. Okay, and then the second airplane want to fly direct from K to L. So if let's say we didn't draw the figure, we just read the question. So it seems like a normal question, right? It's just a normal normal question that can be asked. But if let's say we want to do it by calculation, so we know this is actually is a resultant of two vectors. So how we going to find if a pilot, what direction? So what direction? So from here, okay, how are we going to find theta? Okay, so if let's say we want to use the technique, there are few techniques, but if let's say we want to use the basic knowledge what we have learned in vector, maybe we can use the cosine rule, sine rule. Okay, so if let's say we want to use the cosine rule, right? We want to find m. This is what 300. Okay, so let's say this is 300. Okay, 300. So we have I put here maybe 400 square plus 300 square minus 2, 400, 300. Cosine 35, right? The opposite, so 35. Okay, this one. Okay, I get 231.09 meter. Oh, I have m here, 2m. Okay, just put here lah, 231.09 is the length. Okay, so if the person asks you to find the length, then you know how to find the length by using what you have learned in linear algebra about vector. Okay, and then you want to find the angle. What is the direction? Here we say angle, but in the question is direction. So direction is theta. We can use the sine rule. Sine rule says that if let's say we want to find sine theta, right? Sine theta, the opposite is 300. And then we have 35. 35. The opposite is 231.09. Okay, so theta is 48.13. So the direction, so you can say direction to the north, direction maybe in from north or whatever, but yeah, that is the calculation. If let's say you want to use the what you have learned in linear algebra, so that is one of the application. Okay. Okay, so in this Chartesian plane, you can see there are three vectors, but there is a unit which is n, n referring to Newton. So this is example of a force. So when there is a movement, then there is an energy. There are action, so there is a force, and the unit is Newton. So basically, force is also force has a magnitude and also a direction, because you can see there is an arrow there. So this arrow represents the direction, and also there are angle here, 30, 45, and also the magnitude. So this is also one example of a vector. Okay. Okay. So for example, for this one, we can also find the magnitude of fx, the x component of these three forces. Okay, so we get 6 cos 30, and then we have this one is 0, and then we have this one 10 cos 45, right? Okay, so you get the answer, and then you can find the magnitude Fy. Okay, Fy, and then the magnitude is Fx square plus Fy square. I don't think this is in the linear subject, but it's okay. Okay, tan inverse Fy, Fx. So you learn this. And actually, if you, in previous example, okay, this one is by using cosine rule, and also this one is by using sine rule. Okay, but actually you can apply the same method here. Okay, so if let's say this one, if let's say I change it a little bit, because it must be comes out from the origin, right? So we have, let's say we have 300 here, and then we have 35 here, and then 400 is here. 400. Okay, the direction is just this 0 degree here. Okay, I use the same technique. Okay, same calculation. So my fx is 400. 400 plus, sorry, this is minus 300 cos 35. So I get 154.25. Fy is 0 plus 300 sine 35. So I get 7172. Just a minute, I need to check this. 300 sine 35. 120. Okay. So the magnitude here is 154.25 square plus 172.07 square root. Okay, so I will get 231.09. Okay, so the answer is the same, but this one I'm using the cosine rule, but this one I'm using the formula. Okay, the formula that when we learn cos, okay, we learn about the x component and y component. Okay, and then for theta, fy over fx, so I get tan inverse 0.7 divided with 154.25. Okay, so this one I get 48.13. See, 48.13 degrees. So if let's say you learn this formula in other physics classes, maybe it's actually it's another option, another method to calculate a vector. So whatever because there are few formula developed to find one solution, right? So a force, because force is also a vector, so the way the calculation should be the same. Okay, so this is a force comes from a vector, and as I mentioned just now, force happen because there is a motion, there is a movement. So this one I will talk about this later. Okay, moment of a force. This one is a situation playing a seesaw. What is the relation with vectors? Okay, it's a force. Because why? Because John and Mary is a person that has weight. So of course there is a gravitational force, weight force. Okay, John and Mary weight 81 kilogram and 49 kilogram respectively. Sit at opposite ends of a 3-meter seesaw with a fulcrum in the middle. Okay, so there is a fulcrum in the middle and 3 meters. So we have 1.5 here, 1.5 here. And then if let's say John is 81 G, which is Newton. Okay, 81 kilogram is equal to 81 G referring to gravity, Newton. Okay, and then we have this one, 49 kilogram. Okay, see, Okay, where should their 22 kilogram son sit? Okay, this is a normal situation, right? Normal situation, normal happy family situation. But we make it not so happy because we need to calculate. Okay, so where should their 22 kilogram son sit in order to board to balance? Okay, so if let's say in logical situation, the son should sit beside his mom, right? So maybe the son should be here, 22 kilogram. But the question is, where should the other son sit in order to board to balance? So it means that the person asks you to find the length here or the position of the boy. So what does this related to vector? So for moment of a force, okay, moment, the formula is force times d, right? Force times d. So force times d is a scalar. So this is a magnitude. Okay, so if let's say we're going to find the moment of this John. So it is 81g times with 1.5. Okay, this is the magnitude. But how about the vector? Okay, vector must have a direction. So we will not say the John is at 45 degrees because there are no angle here. Or maybe John is at the north. So there is also no direction of north, south here. But how we represent the direction? We will represent the direction by using clockwise or anti-clockwise. So if let's say this one, we have a point here, and then John sit down, and the seesaw will, I'm not sure whether you understand or not, because it's not in the linear algebra, but if let's say the force is down here, and the fulcrum is here, so moment of this point here, it will be like this. Anti-clockwise. So this is a vector. This is the magnitude, and also this is direction. So how we represent the direction? Magnitude is easy to see. It is a magnitude because it's represented by a number. But the direction here is represented by anti-clockwise or clockwise. Okay, so it is anti-clockwise. So you have how many force? You have 1, 2, 3. So you can calculate the moment. The second boy here is 22g. Okay, this is 22 kilogram. But if let's say in Newton, it is g. Okay, it is g Newton. This is also g Newton. For 49, 49g. Okay, so 22g. The distance, we do not know what is distance. And if let's say this is going down and you have this, so it is clockwise. And then we have 49g, and then the distance is also 1.5 clockwise. And the keyword is balance. So balance means equilibrium. So it must be equal to 0. Okay. So now the direction is anti-clockwise, clockwise, and clockwise is not the same, right? So what about if let's say we make it same? The direction would be clockwise. So 81, if I have the answer here, negative 121.5g clockwise. I have 22g x clockwise plus 73.5 gram clockwise is equal to 0. Okay, now it's all in clockwise. So I have 22g x clockwise. Okay, I just put 22g lah. x equal to 48g because we want to find x at where x is 2.15 meter. Okay. So 2.18. 2.18. Where is 2.18? Okay, from here to here is 1.5 meter. But the answer here, the boy should sit 2.18. How are you going to sit? So the boy cannot play together, cannot play with his mom and dad. So that's the answer. Cannot play, main jauh-jauh. You cannot play with us, the mom says. Okay, so actually the boy can play, but the board will not balance. The board will not balance because it will move. If let's say the boy sit here, if let's say this is the seesaw, it will, because this is clockwise, it will be like this. It will not balance. Okay, it will not be balanced. Okay, you can try number 2. 36 kilogram daughter sit in order for the board to balance. Okay, the daughter will sit also here, but 1.3 meter right. Okay, it's actually 1.3 meter right from the fulcrum maybe. Okay, if let's say you have a diagram, then it's okay to answer like this. Okay, so you can just put X, or you can just answer 1.3 meter right from the fulcrum. Okay, so that's I say this is actually from a vector. We cannot see if let's say we don't calculate, we cannot see this is actually an application of a vector. Okay. Okay, and then motion of an object. We learned just now I said about velocity. Velocity normally we will compare it with a speed, right? If let's say I'm moving 40 meters per second, so this is a speed. If let's say I am moving 40 meters per second to the north, so this is a velocity, but it's actually the same, maybe the same situation, same motion. Okay, but if let's say we add some velocity, some direction, then it becomes a vector. So if let's say a velocity is what, halaju. Okay, so we may relate it to displacement. It different with distance, right? If let's say distance, if let's say you have point A, B, and C. So the distance from A to C is is the length from A to B, and then you add with the distance between B and C. So you get the distance from A to C. But for displacement, you only consider the final and initial position. So if, for example, I have this, I just took whatever around me. Okay, you have a bottle like this. So if let's say the initial position, initial displacement of this mouse is 0. Let's say this is 0. Okay. If let's say the final position is up here. So it is positive. Let's say this is 10 centimeter, let's say. So the displacement, this is the initial position. This is the final position. So we can say the displacement is positive 10 centimeter. But if let's say the displacement is down, this is the initial, and then is the final position. So the displacement is negative 10. So my conclusion is that 10 is the magnitude, but positive and negative shows the direction. It shows the direction. When we see the displacement, if let's say we say the displacement is negative 5 meter, means that we know that the final is down, is lower position than the initial position. So we do not say the direction in angle, in northeast, in what anti-clockwise, clockwise, but we represent the dimension, the direction by the positive and negative sign. Okay, same goes with velocity. The velocity of a car is a measure of the speed, which is traveling at a particular direction. If let's say it's moving to the right, so it is +5. Let's say moving to the left, okay, it's -5. So indirectly, it shows the direction, but we always sees that -5 is a scalar, it's a number. So we didn't realize actually -5 means the magnitude is 5, the direction is in the opposite side. So same go as acceleration. Positive acceleration means the object is speeding up, but negative acceleration means slowing down, or maybe is pressing a brake, car brake. Okay, so how we represent the direction is by using the positive negative sign. So it's actually a vector. Okay, so it's a motion of a object. Okay, so if let's say you see this is a graph of motion where we have the meter per second represented by a velocity, a velocity time graph. So we can see that velocity, we can say it's a speed, right? Laju. It's 2 meter per second, 4 meter per second, but that is a -2 meter per second. Does the negative means the motion is not, the object is not moving? Yes, it is still moving with the magnitude. You cannot drive a car and then it is negative. You have the speedometer, right? 110 meter. Okay, your speed may be 110 kilometer per hour, but your velocity may be -110 kilometer per hour. Does the speedometer shows negative sign? No, right? Because the speed remains 110, but maybe the direction. When we say about velocity, maybe the direction is at the opposite side. Okay, so that's why velocity can be negative. It's not the speed is negative, but the direction is negative. Okay, so if let's say you have this one, describe qualitatively the motion of the leaf. So it's actually situation, a motion of a leaf, but the leaf, but we represent by a V. Okay, so if let's say you look at here, there are few phases, 0 to 5 seconds. The leaf moves upward. That is a keyword for vector direction. It's moving upward. And then you see at 30 seconds to 35 seconds, it's moving downward. So upward and downward. That is the direction. And then the magnitude is 4, 2 here. Okay, and then 0. Upward from rest. How do we know it is from rest? Because V is equal to 0. It is static. It's stationary, doesn't move. Okay, with a constant acceleration, because velocity, when you want to find the acceleration, if let's say from the graph, you can find the gradient. This is 0, 0, this is 5, 2, right? Okay, you just find the gradient. So the gradient is 0.4 meter per second. You know the acceleration, the pecutan, how fast, how the speed changes. Okay, is 0.4 meter per second. So you know how the motion of a leaf. But in normal situation, okay, the leaf is speeding up, the leaf is going upward, is going downward. But in mathematical calculation, this is how you know, how you calculate. Okay, 5 to 15 seconds, the velocity of the leaf increases from 2 to 4 meter per second. So from the graph here, you can see from 2 to 4 meter per second. Okay, and then rest or stationary and so on. Okay, So it is related. Displacement, velocity, and acceleration. The acceleration maybe you can find from the gradient, but for the displacement, you can find from the area under the graph. So you can get the distance or also the displacement. Determine the total distance traveled by the leaf and its displacement. So just now I just mentioned about the difference here between the distance and displacement. So you need to check, let's say this one, 0, 2, 4. Okay, I don't have the solution here, I think. But this is, I just want to show that it is related. From velocity graph, you can find the acceleration. So it's all about the motion. You can find other things. Okay. Okay, how about this one? This is just a simple question, right? A baseball is thrown straight upward with speed of 30 meters per second. Speed is the magnitude, 30 meters per second. What is the direction? Direction upward. But normal people will see, oh, just a ball and then throw up with a speed. But actually it's a vector. It's actually a vector. So after this, if let's say you see whatever object flying around you, you have to imagine, oh, actually there is a force, there is a vector, and how calculated, how you're going to calculate, how long will it rise, how high will it rise, how long after it leaves the hand will it return to the starting point. So this is a normal question, okay, normal question, but you can calculate it by using the formula for constant acceleration, right? Like v square is equal to u square plus 2 gs minus 2 js, v equal to u minus gt, okay, and so on. Okay, if let's say you have more complicated question, this is a two-dimensional, just now is just one-dimensional, right, vertical throwing. So this one is projectile question, two directions. So you learn about vector just now, right? You have an x component and y component. So this one also you have a x component and y component. You need to check. So if let's say you have u here, you have u here. So is it uy or ux? Or is it just velocity? So velocity you can divide into two. And also the x component, y component, sorry, ux and uy. Okay. If you are given ux and uy, you can also find u. So there are so many things to play around, but actually it's come from vector. Okay, a transport plane traveling at a constant velocity, 50 meters per second, at an altitude of 300 meters, release a parcel when directly above a point. So throwing a bomb, throwing a parcel here. So how do you calculate the R, the range, the distance, the height? Okay, how far, how long it will take the parcel to arrive at the ground. So many things, okay, that you can find from one simple question, okay? Okay, and then we move on to Newton's law. Okay, this one is a simple example. A box is on an inclined plane. Normal people see there's only a box, but mathematician, you need to see through the situation. Oh, that's not a box. There is a box, and then the box has a weight, and the weight is also it always pointing down. And because of Newton's law, third law says reaction must have a action must have a reaction. Equal, opposite, the force must be parallel to the surface, must be perpendicular to the surface. You can draw in your mind. Okay, if let's say it's a rough surface, you have a frictional force. So all the forces is a vector, comes from a vector. The calculation would be the same. You can use the cosine rule, sine rule, or you can just use the force, how the x component, y component. Okay, or maybe it's just a simple question like this: a net force of 10 Newton X on a box. Okay, it's only a box, and then one people pulling the box, or maybe like two boxes. So the situation can be more and more complex. Okay, you have a pulley system. you have two boxes. What is the acceleration? What is the tensional in the string? Okay, you have a tensional force because there is a string. You have a rope. Okay, so you have a tensional force. Or maybe the box is on an inclined plane and then it is held with some what dinding here. Okay, so it is pulled down, pull down, pull up. Okay, whatever situation, you need, you can find it. It can be more and more complex from the basic. Okay, so I think that's all the example that I conclude here. Okay, so actually we know that maths is important. The only thing that is maybe we didn't see it yet, where to apply. Like you undergraduate, you're not into depth, learning each of the concept. You just learn about the concept, but maybe the application is not touched yet. But you know that it's actually is applied to your real life, but maybe do not, we cannot see it if, let's say, we do not jot it down or maybe read it. Okay, so it's good. Just learning maths, this is just a general thing. Learning maths is good for your brain. Yeah, people see it's only a box, but you see everything is on the box. Okay, maths helps you tell the time, how long the box, the parcel arrive at the ground. Okay, so you tell the night how the people has a cancer, when he will be dead. So you calculate it first. Estimation time of death. Okay, maths. Okay, that's just a joke. Okay, maths helps you with your finances. Okay, if you save gold right now, in 5 years, 10 years later, how much per gram the price of the gold makes you a better cook. You want to bake some cookies. If let's say you want to double the recipe, how many cookies they will have. Okay, so it's like a problem solving skill, and actually it will be practical to every area. So there are a few websites that I would like to recommend you to look at, because they share how mathematics or science, basically science, helps. But currently I like Aja. Aja is a Malay website, YouTube. This is a YouTube channel. So it's a YouTube channel in Malay. So it's very funny, quite funny. So if let's say you look at my research background, I don't have any background in research in algebra, but more to fluid dynamics. So if let's say any one of you or any researchers in the same field like to share or collaborate in writing research or do some research, or you want to study here in Malaysia, then you are very welcome. Okay, so okay, this is just a publicity, so I will take some time to do some publicity because currently I'm an editor of this journal, MIJ UiTM journal. So if let's say you have any research or any manuscript that that falls into mathematics or maybe computer science, maybe then you can feel free to look at the website and then submit your manuscript. Okay, I think that's all from me here from Tapa Campus, Malaysia. And if let's say you have any question, then feel free to ask. Okay, thank you.
Okay, thank you, Dr. Nurul. Okay, please give applause for Dr. Nurul. Okay, is there any question for Dr. Nurul? If you have any question, please mention in the chat or you can raise your hand. Okay, don't forget to fill the attendance form. I already sent it in the chat. Okay. Okay, waiting for your question. Dr. Nurul, I have 2 questions.
First, okay. First, do you have any suggestion for the book that related for linear algebra application? And also, is there any software for supporting this subject? This is the first question. And then second, do you have any suggestion for student research, topic that related with linear algebra? Thank you.
Okay, thank you. Okay, for the first question is about linear algebra. I don't have any specific books. And also, actually, I don't have any books in my office because I have two offices. So I don't have any books here, or at least I can show, but I don't have one. Okay, so I don't have any specific books on linear algebra. Okay, second question, I use Maple.
Oh,
MAPLE software to do some calculation on matrices, Gauss-Jordan, Gauss elimination. In 1 second, you can get the answer using Maple. Like you do the ERO, right? The Gaussian elimination method. Using the software, you just have to click how many matrices, how many row, how many column, and then in 1 second you can find the answer, and step by step. So I use Maple. Okay, the third question about the research area, is it? Okay, as I say, I don't have any background in algebra research, so I don't think I can share or but I do have students because for linear algebra here, we ask the students to do some, there are one assessment on, they need to do some case study about linear algebra, what they learn. So I did share this on previous session. If I have some time, do I have some time to show?
Yeah, you still have. We
Uh,
stop in 2:50. So you still have time around 10 minutes or 15 minutes.
Okay, I have one, this actually, I have shared last semester to the business student. Okay, I'm sharing you the slide. Maybe you can get some ideas. Okay, where's my share screen? Let me show you this one. In June 2020. Okay, application of linear algebra in real life. Okay, these are the case study that the case study that I showed here is actually from my students. I take from their, because they need to do one group assignment. They need to find one case study related to linear algebra. So many of them use, I think because my topic is matrices, so I only take a matrices case study. So the first problem, okay, I need to, okay. So the first problem is about fishes sold in market. Okay, so the info given is fish in kilograms sold in each market, and then cost for 1 kilogram for each type of fish. So the objective is estimate the total amount of sale for each market. Oh, I think this is not okay, later on. Wait, yeah, I check back the slide. This is not the last one. July. Okay. Okay, maybe. Okay, I think maybe I can just share this. Where is my? Okay, can you see my screen?
Yeah.
Okay. So this talk, in this seminar, I talk about the application in geometry, in linear algebra. So for linear algebra, I think it's big enough, right, to see. Can you see my screen?
Yeah.
Yeah.
But
I need to zoom, I think.
but yeah.
200 or too big. So can you see my screen?
Yeah.
Okay. So linear algebra, this is the example given. Example 1 is about food, roll, bun, cake, and then the quantities and also the prices. It is arranged in an array. So of course, it is arranged in a table. Then you can arrange it in the matrices, right? So the question is maybe each of them needs which shop is the best for every person to pay as little as possible. So this first example is, the quantity and also the prices, and then the objective is to find the best shop. Okay. For example, 2, okay, it is in cryptography. Crypto, how to decode. Okay, it's actually from algebra. Okay, let us singular and then they decode or something like this. Okay, but they did the research. Okay, and then this is for diploma students. Okay, but they do not just a simple one like this one, analyzing and predicting of traffic flow. So there are traffic like from point A, B, C, and D, and then they do some assumption. Okay, but this one is actually system of linear equation. Okay, right, from intersection A, and then they do some simultaneous equation, and then simplify in a metric. It's just simple like that.
Before from the previous about the traffic, I think, and slide 12, yeah. How they get the data? The student observe in the street or something.
I think either they just put a value there, take a value there, because they are just undergraduate students and we don't expect them to get the data, real data. So because we just want them to know that how to apply what they learn in real case. Because we don't teach about traffic, right, in class, just the equation, how to calculate the system unit equation and so on. So that's what I said, that I don't have any background in research area or algebra, so I cannot comment. But that is some sharing from my students, just a basic knowledge on, maybe if let's say the student, if the question is asked by a student, maybe they can get some insight. But if let's say for lecturer, I cannot, maybe I cannot help to give some more powerful research.
Interesting. Okay, is there any question? Okay. Don't forget to fill the attendance form, yeah, and then waiting for your question. Okay, let's get picture together. Please open the camera. Okay, Okay, we have 5 slides. Okay. So many people doesn't open the camera. Please open. So, Bernard. Okay, first slide. Okay. Okay. Is there any question?
May I ask
Yeah.
how to use linear transformation maybe in 3D space?
Could you please repeat again?
How to use linear transformation in helping to calculate in 3D space?
Dr. Nurul, can you answer directly?
Linear transformation, is it?
Yeah.
Yes. And another question, may we use complex number in vector? Thank you.
Okay. Your question is your question are first about how to use linear transformation in 3D, right?
Yes, to how to use linear transformation in propagating 3D in the 3D space. For example, if we 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 mostly use vector in 2D space, right? Like vector addition, vector subtraction, and so on. What about 3D space? Would we have IJK, for example, or something?
I need for this. I think maybe you can email me one type of example. Maybe I'm not very clear on that.
All right, that's okay.
Okay, Dr.
Sorry.
Nurul, can you share your email?
I think okay. I just put in the chat. I think.
Actually, for this topic about the how to implementation of linear transformation in 3D, you can learn in geometric algebra. There is a topic that focus on how to apply linear transformation in 3D. There is a book that focus on it, geometric algebra.
Okay, thank you.
And the second question, what about? Sorry, I forget.
Can we use complex number in vector space?
Oh. Complex number.
Have you learned about axiom?
Yes.
Because I'm not sure. I'm not sure on that. Actually can, but I do not know whether you have learned. Do you learn about the axiom? I do.
Yes, ma'am.
There is a calculation there, right? Your question is in 3D. What is the question again?
Can we use complex number in vector? For example, in complex number, we use vector, right? How about the reverse? We use vector in complex number. Are we able to use vector in complex number?
I never did that. Because normally, like, because for vector, we have, if let's say the vector is 2, 3, right? 2 is the x component, 3 is the real number. I mean, we don't have any complex number for vector. If let's say in further study, maybe, I do not know, but I never done in complex number.
All right, ma'am. Thank you very much.
Okay.
Is there any question? We still have time around. Okay, we have no time again. 2:50, and don't forget to fill the attendance form. Yeah, I already sent it in the chat. Okay, Dr. Nurul, I would like to say thank you for your great talk about the vector, and hopefully we can get the insight from this webinar. Okay, thank you for all for attendance for this seminar also. Good afternoon.
Okay, thank you. See you again.
See you, ma'am Nurul.
Okay, assalamualaikum.
Halo Ibu Afi.
Halo Pak Wikarya, apa kabar Pak? Terima kasih udah join.
Terima kasih juga. Saya dapat dari Pak Nurjali link ini.
Oh,
Filmnya bagus juga ya.
ya.
Itu aplikasi vektornya gitu.
Jadi ini jadi bahan untuk ujian nih Pak. Jadi lumayan nih.
Iya.
Mungkin nanti kita jadi bahan pertimbangan karena materi vektor seringkali ini ya kurang aplikasi. Dan ini kayaknya kita sering ini tidak mention masalah arah juga ya.
Oh ya, arahnya ya pengaruh kan?
Iya. Nah, jadi ini kayaknya jadi bahan kajian untuk ujian nih.
Itu videonya bisa diperoleh nggak Bu ya?
Oke, nanti Pak saya minta ke bagian LSC, nanti saya share di grup mungkin ya Pak ya.
Oh itu LC yang itu ya?
Iya.
Yang waktu saya berikan waktu saya di moderator gitu, saya minta ke Ibu Ajek gitu ya.
Iya. Ini nggak tahu tadi LSC kami dari binus Vikonnya, link Vikonnya beda ternyata Pak. Jadi mungkin nanti saya minta ke Bu Ajeng juga sih. Tapi tadi sudah koordinasi sama LSC-nya.
Oh gitu.
Kalau kemarin Pak Wi udah terkoordinir dengan LSC enggak link Vicon ini
Eh,
terkait absensi sih?
waktu itu di ruang 408 saya waktu itu minta apa ruangan dari ERC-nya.
Enggak, link Viconnya sama dengan di
Sa-
Bima ya Pak ya?
Waktu itu sama.
Oh oke, saya yang masalah ini. Jadi link di Vicon Bimai dengan link dari Bu Ajeng berbeda.
Oh gitu.
Jadi hari ini saya harus.
Oh iya sorry. Link yang pertama yang sebelum maksudnya sebelum dijalankan beda memang beda. Akhirnya saya tanya lagi ke Bu Ajeng kan. Akhirnya Bu Ajeng kasih yang baru.
Tapi di absensi mahasiswa aman ya Pak ya?
Waktu ini absensinya agak terpisah Bu dengan ngajar sama kuliahnya.
Oh.
Kuliahnya pagi, dia sore nih kan yang acara 1:30 sampai jam 3.
Tapi absensi aman ya Pak ya di Bimai?
Di Bimai absensinya waktu itu absensi kuliah memang tidak digabung dengan ini Bu.
Oh baik Pak Wi.
Terpisah seperti Pak Faisal terpisah juga.
Oh oke. Baik
Ya.
Pak. Nanti saya ini apa untuk absensi juga perlu dicek lagi nih.
Iya.
Ya.
Banyak yang hadir waktu itu Bu.
Oh gitu ya Pak.
Dia kaget ya Pak itu Dokter Muhammad Azhari.
Iya.
Banyak ya. Waktu itu ditanya Mas saya sekitar paling 28 dia bilang gitu kan.
Iya.
Ternyata waktu itu jumpa hari H-nya juga tapi belum main masih siang. Jumpa dengan Pak Samsul. Saya bilang nanti ada itu Pak Samsul minta linknya. Mungkin mahasiswa Pak Samsul masuk lagi. Jadi tambah banyak.
Oh jadi berapa Pak kemarin?
Waktu kemarin kalau salah ada sekitar 94 ya salah.
Oh lumayan ya.
Ya, jadi mungkin mahasiswanya Pak Samsul juga gabung gitu. Jadi tambah banyak. Dan atau ada juga masalah. Cuma dari kelas saya sedikit sih, nggak banyak.
Oh oke. Kalau ini memang waktu kuliah mahasiswa saya, tapi yang banyak kayaknya dari luar juga sih. Ini 120-an.
Iya.
Oke.
Iya. Baik Bu, nanti kalau ada linknya tolong Ibu ya gitu.
Baik Pak, nanti saya sampaikan.
Baik.
Oke, baik.
Makasih Bu Alfi.
Saya juga makasih.
Ya.
Semua mahasiswa sudah ini ya, sudah ngisi form ya.
Oke, saya izin live ya.
Oke ya Pak Wi.
Makasih Bu Alfi.
Sama-sama. Semuanya sudah ngisi ya. Erin, Hugo, Bernard udah ngisi belum?
Udah Bu.
Oke deh, kalau gitu, kalau udah semua, aku tutup ya linknya ya. Ya, semuanya udah absen ya? Halo?
Absen udah Bu.
Oke, ya udah, boleh live deh. Aku nungguin, takutnya ada yang belum isi. Coba.